to 20. Absolute values have 2 solutions. So you have to make the positive and the negative. So you have 5c equals 20 and 5c equals negative 20. So then you get c is equal to 4 and c is equal to negative 4. And you would plot both as solid points on the number line. In example 2, same idea. You have your absolute value. You're going to split it into both the positive and the negative. So you'd have 2 minus b equals 10, as well as 2 minus b equals negative 10, and you solve both for b. So 2 minus b equals 10, so you subtract 2 from both sides. Negative b equals 8, or b equals negative 8. And then on the other side, you would have 2 minus b equals negative 10. Subtracting 2 from both of those sides gives negative b equals negative 22. Negative 22. Wow, negative 12. And then divide both sides by negative 1. And we get b is equal to 12.
I have a question.
If it's about our class in math, I can't help you right now. I'm teaching a lesson. So you plot 2 points on your graph. So you have negative 8 and you have 12. Both are dots on the number line. Good? So absolute value inequalities are a little bit different than absolute value equations. So an equation is equal, you get 2 solid points. An inequality is open in the sense that you can have many, many, many answers. So in 2h greater than or equal to 8, this is great or, so this is an or absolute value inequality. So you still have to split your problem into the positive and the negative, where you flip your inequality and write the negative sign. Solve both sides for h, so you divide by 2, and we get h is greater than or equal to 4, or h is less than or equal to negative 4. So very similar to number 1, in that we have 4 on my number line and negative 4 on my number line. And both, again, are points because it's greater than or equal to or less than or equal to. But now we're shading outwards because h can be bigger than 4 or less than negative 4, meaning h could be 10. And if you plug 10 in, it would still be true because 2 times 10 is 20, and 20 is bigger than 8. You could plug in negative 12, and it would still be true because negative 24 inside the absolute value is 24, which is still greater than or equal to 8. So like we've been doing, we're going to graph our equations and shade them. The in and the out is still going to hold true, but now instead of graphing lines, we're going to graph absolute value graphs. And if you recall, absolute values look like A, E. So y equals A, absolute value of x minus h plus k is our general formula for an absolute value. Now instead of equal signs, we're going to have inequalities happening right here. An absolute value graph looks like a V. The vertex of the absolute value graph was what? What was the ordered pair for the vertex? It was always comes from this. and H.
Wow, I'm on a roll.
So H comma K, where the H was the opposite of what was in the problem, and the K was the same. So remember, H moves you left or right, K moves you up or down. What did the A represent? The slope. Excellent. So let's take all of that into account and graph some absolute value inequalities. So now instead of just being a graph like this, we're going to have some shading that goes with it. It means we have many, many, many answers again. So we have y is greater than or equal to the absolute value of 2x minus 3. That is the same as y is greater than or equal to 2, absolute value of x minus 3. Because the 2 in or out doesn't change it. That 2, like we just said, represents my slope. So a is equal to 2. That's going to be my slope from the vertex to the right. What is my vertex? So what's the h value?
-3.
That's my k value.
Oops, wrong one.
Not 1. Yeah, the h value is going to be 0, which makes my vertex 0, -3. Plot that point. Now, going back to the inequality rules, just like for lines, is this absolute value graph going to be solid or dashed? Solid, because it is equal to. Apply the slope, so it goes up 2 over 1, up 2 over 1, up 2 over 1. Absolute value graphs can be taken and folded in half, right? So if I go up 2 and right 1, I also go up 2 and according to my old rule, if it was y greater than, you shaded above or below? Above, right? So if you look at these graphs, where's the above going to be? Are you above the line inside the V or outside the V?
Inside the V.
Inside, good. So my above, in this case, where's the lines? What's above them? Inside them. That above and inside doesn't always fall true if the graph is upside down. So it's more above the line that you're falling into play. How could you check this? What point could I pick? That's a nice point to pick. Yeah, pick 0, 0, right? If I plug 0, 0 in, should it be true or false? True. So 0 greater than or equal to 2 times 0 minus 3. Anything times 0 is? Absolute value of 0 is? So 0 is greater than or equal to -3. Is 0 bigger than -3? So it is true. So that means my test point is a solution. So that this point 0, 0 is true. That means that it is also a solution. So if I ask you to give me a solution, 0, 0 is a solution. Number 8, or 2 or 3, whatever your numbers are. Yeah, they get all goofed up when I make like different slides. What is the vertex? Because that's the most important part. Yep, opposite of the inside, same as the outside. So -2, -3. Plot your vertex. What is my slope? What's in front of the absolute value? 1. So I'm just going up 1, right 1, up 1, right 1, left 1, up 1, left 1, up 1, left 1. Now, is this absolute value going to be solid or dashed? Yeah, it's dashed because it's greater than, but not equal to. Now, y is greater than. So it's the same question as before. Where are the y values going to be above the line? Because greater than is above. So in the V or out of the V? In the V. And we could check this once again with my favorite test point of F. And it is, once again, true. Okay. What do I have to do in the next example that I didn't have to do in the previous ones? Get the y by itself. So we're going to subtract 3 and divide by 2. That dividing by 2 still creates my slope. Good. My vertex still comes from H and K. So it's the opposite of the inside, same as the outside. So my vertex is at 5, -3/2. So you go to +5, down 1.5, because 3/2 is really like 1.5. And then my slope is -1/2. So that negative tells me my graph is reflected, which means it's going to be open down. So you're going to go down 1 and over 2 from your vertex. You're going to go down 1 and over 2 from your vertex. So you're going to be in between each of those lines. Is this graph solid or dashed? Good. And my y values, once I simplified this, are less than or equal to. So that means they're below the line. So now, if they're below the line, where's below my lines? Inside or outside? Inside again. So do you see how, like, the inequality, you have to really pay attention to the lines themselves, not the direction of the inequality? So there's not like this role of like greater than's out, less than's in. It's more the lines and above or below still. So y is less than, so it's below. Where's below? Inside. Okay. solve for y. So subtractor 2. Now this time you have negative y. If you divide an inequality by a negative, what does that do to the sign? Flips it. So it's y greater than negative absolute value x plus 3. The negative stays on the outside of the absolute value. It doesn't go to each piece inside. It does, however, make my 2 a positive. So what is my vertex? Perfect. It's negative 3, positive 2. What is my a value? Yes, which means my graph is open down, which means my slope is negative 1. So you plot negative 3, positive 2. And from each of those, you're just going down 1, right 1. Is my line solid or dashed?
Yeah.
The y values are greater, which means you shade above. So are we inside the inequality or out inside the absolute value or outside the absolute value for above? Outside. Okay. Your homework is the next page in the packet. There are 4 graphs. We will check and go over each of those tomorrow. We'll review tomorrow, and then as long as our review goes pretty well, our quiz will be Wednesday.